All right, so problem 4 here, right? Let's do another problem 4. An 85 ohm heating element is connected to 120 volts. What will be the final temperature if it's initially at 21? If it heats it for 27.1 minutes. Oh, all right. So remember the concept map is this: that power is work divided by time, right? Power we're going to get from some formula, right? Here we have R and V, so it's going to be V squared divided by R. Right, but remember in general, power is IV, right? Is I squared R, is V squared over R, right? But this one's V squared over R. Okay, let's see. And then we're heating up water. I guess we have the power and we have the time, so we're going to find the work. Okay, so that's my first step. Okay, let's find power. Power is V squared divided by R. So it's 120 squared divided by 85. That's 169.41. Okay, the second thing I'm going to do is I'm going to figure out how much heat that thing evolves, because remember that's joules per second, right? And it's 27.1 minutes, right? So 169.41 joules per second times 27.1, and this is minutes. And then of course we got to go, what, 60 seconds per minute. And then if you look at the units here, minutes will go away the bias, and seconds will go away. We'll end up with just joules. So let's figure that out. So I'm going to multiply times 27.1 times 60. And this is our, wow, that's quite a lot of energy. Okay, so that is 275,463.53 approximately joules. Okay, so that's how much heat the heater's going to put in, right? And then we're heating water. We're given the specific heat capacity of the water. This is a big clue that work in this case is MCAT, right? Okay. The other thing it will be is MGH, but in this case it's MCAT. Okay. So our third step is we just say Q is MCAT. And so 275,463.53 is, what's our mass? 3.78 times C, 4186 times delta T. Remember that this will not be the final answer. This will just be how much the temperature increases. We'll have to add that to the 21. But okay, here we go. So I'm going to take this number that's on my calculator, divide by 3.78, divide by 4186, and I get that the temperature rises by 17.4. 17.4 degrees Celsius, so the new temperature, the final temperature. 4-step problem, this is awesome. Okay, so the final temperature is 21 degrees that it starts off, right? And then we add 17.4, and we get, so add plus 21, and I get 38.4089. 38.4 degrees Celsius. Ta-da. Which is our answer. It always has these parts. All right, good enough.